Hello, this is Lisette Rincon, and this is my 5E lesson plan. This grade is for 5th grade, and the performance expectation is 5PS 1.2, measure and grab quantities to provide evidence that regardless of the type of change that occurs when heating, cooling, or mixing substances, the total weight of matter is conserved. And it is important to note that one of the assessment boundaries is that in this grade, mass and weight isn't defined, is not separated. So if they say mass, it's okay if they say mass when they really mean weight. Later on, they'll be able to distinguish between both. Now for my engage phase, I wanted to send them a formative probe assessment through Google Forms. And so the water weighs 250 grams and the salt will weigh 150 grams, not like you see it on the screen. That was for another assignment for this class. And then the questions, instead of giving them a selected response answer, I would just give them the question and then for them to explain their answer. Like I want them to see the question, look at the substances, and then explain what they think the resulting weight will be. I want them to be thinking about any of their previous experiences with this type of question. And I chose salt and water because the salt dissolves into the water, and so I want them to think, oh, maybe it doesn't weigh, maybe the salt isn't involved in the weight of the water afterwards. Now, after discussing in the engage phase about the different answers to the probe, we would begin the explore phase where I asked them to watch ice and chocolate melt, first weighing them on a digital weight scale. They would weigh them as solids, watch them melt, which I would go around blowing a fan to help the substance melt a bit faster. And then they'd weigh it again as liquids, and then we put it back in the fridge overnight to weigh them again as solids once again, so they could see the process of them melting and how it weighs as a liquid to when they come back as a solid, a full circle of it. Hopefully, some weight might be lost a little bit, but hopefully on this scale it won't read that much. And then they would also have sugar and water to mix, so it can relate back to the salt and water, except this one is sugar and water. They would weigh the substances separately on the weight scale, then they mix them together and weigh it together to see how both of the weights are still intact even if the sugar dissolves. They also are doing making their own graph. You see the graph that I have here is blank, and they also have to write 2 observations in full sentences. And this is where the science and engineering practice is introduced. They have to use mathematical and computational thinking by representing data in graphical displays, in this case a bar graph. And they have to make sure that they enter all the necessary parts of a bar graph for it to be counted correctly, because I was going to use a rubric to count to make sure that they do put their observations, they put all the correct items in the graph, and that they actually weigh their items correctly. After our discussions about their findings in the explore phase, we would then move into the explain phase, where I would basically go over the disciplinary core ideas, which is that the amount of weight is conserved when it changes form, even in transitions in which it seems to vanish, and that no matter what reaction or change in properties occur, the total weight of the substances does not change. And once again, the boundaries that mass and weight are not distinguished at this grade level. And in this phase, I would go over this great simulation that I just recently found, and it basically shows different substances mixing, and even at the end, the magnesium sulfate and the sodium carbonate, that even when they are mixed together, both of their substances are still included in the weight. I want to make sure that they can see these things because when mixing, you aren't really able to see the little molecules as they get smaller. So this is a great simulation to show the students. And then afterwards, in order to introduce to them the vocabulary, I would have a little card game called the matchmaking activity. We would have the heating, cooling, mixing, and conservation of weight and dissolving terms. And instead of having definitions of them, I would instead have other terms that correlate with those, such as the ones that you see there. So on those other terms, the ones circled in green, those are terms that are a process of heating or are a process of cooling. And on the back of those terms, circled in green, those have definitions of that specific process that it is. And for the other, for mixing, conservation of weight, and dissolving, I'd have examples on different sheets of cards. Examples of what it is, what conservation of weight is, what it is not, and the definition of that. And what the students would do, I would hand them cards of the heating, cooling, mixing, etc. And they would have to find the cards circled in green. They'd have to find the match to them. And then after they found their match, the students would go against the wall and we would go student by student, term by term. We discuss each term, and if they got it wrong, we discuss what maybe the right term is. And that way everyone has a chance to look at any term that they have and then hear other terms as well. Now, in the elaboration phase, in order to extend some of the previous knowledge that they have already just learned, I would have them do an experiment once again on using milk and hot chocolate powder. I'm doing this because the milk, it might weigh differently than the water, and I want them to see how even though different substances have different weights, it doesn't matter because the substances mixed together, they're still going to have that weight. Once they're mixed together, it's still going to contain both of the substances' weight. And in order to incorporate technology, I would have them create the graph and their observations on their Google Drive on their Chromebooks, hopefully. And so at first they go into the Google Sheets to create the items in the graph, all their data. And then after they create their graph, they put it into the Google document and write their observations. And then after that, we discuss what they have recorded, all their data and observations. And after reinforcing those disciplinary core ideas, we would watch a YouTube video about metals melting. I have this coin video right here, which shows different metals, the different coins melting together. And it also shows how the weight is still relatively the same. It also includes how weight was lost a little bit because of certain things that he did, but still it is still really close to the weight had, and it probably would still be the same had he had not done all those things to take away some of the weight. In this phase and in the explore phase, they're also incorporating the cross-cutting concepts of scale, proportion, and quantity, which says that standard units are used to measure and describe physical quantities such as weight, time, temperature, and volume. So in the graphs, they're using weight and temperature as well because the items are melting or mixing together. And so they're comparing the two and viewing them through that lens of weight and when they melt and when they freeze again, when they mix. And so that cross-cutting concept is used in both the elaboration and the explore phase. And finally, in the evaluation phase, I would give them a small quiz over the terms that they learned in the explain phase. They would have a word bank and the definitions or examples of some other terms written out for them, so they'd have to place the correct term next to the correct definition or example. And then after that, we would discuss some test questions. I wrote these test questions for another class, but here you can see I have one where it includes a graph so that they once again are using that scientific practice of using or representing data in graphs, and this time they're reading them. And it also has some other questions that you can see here just so they can have an example to see how this lesson can be applied to a test. Finally, I would ask the students to record in their science notebooks the main ideas that they took away from this lesson using correct sentence structure and vocabulary terms. It allows me to assess what the students have learned after going through the whole lesson and if there needs to be any further exploration phases for the students to understand the core concept of this standard, and it allows the students to assess themselves of what they have learned so far and if they need any further clarification. I would also leave any small notes at the end of their entries to remind them to use some vocabulary that we've discussed and just some positive feedback if I can.